All right, so here are your notes 4.9 for the Honors Algebra 2 course. Two objectives in these notes. First one is to be able to graph quadratic inequalities in two variables, meaning there's going to be an x and a y. So in order to graph these, it's not going to be on a number line. It's actually going to be a x-axis, y-axis, or a coordinate plane. So first off, we're going to graph inequalities, and then we're going to solve quadratic inequalities with one variable. These two are very closely related. I'll show you towards the end of the notes how it works out that they are very much alike. So, all right, so moving on. So graphing inequalities in two variables. So these are some general steps that you can take to graph these. This is not the only way to do this, but this is the way that I showed my class. So this is very similar to how you would graph inequality, um, the linear inequalities. First, you got to find if the line is dashed or solid, and then you got to figure out which side to shade by testing a point. So you're going to draw your boundary. It's not a boundary line. It's a boundary parabola because it will look like a parabola. You're going to figure out if it's dashed or solid. If it's less than equal to, if there's an equal to part on the bottom, then it's solid. If there's no equal to sign, then it's going to be dashed. Next, you're going to test a point either inside or outside of the parabola. Depending on if that point works or not, you're going to know where to shade. If it doesn't work, you're going to shade the opposite side. So basically what's going to happen is this. You're going to graph the parabola just like using the methods that we've learned before. So say you ended up with a parabola dashed going like this. So you graph a parabola, you know it's dashed because when there's a line underneath like this, that indicates, well, like this, that's going to indicate that there's going to be a solid one. So this one that I just drew would not have an equal sign on the bottom. All right, next thing you would do is you'd take a point, you'd test a point either inside, if you think of this kind of like a cup, you can think of this inside, this part is the inside of it, and this part is the outside. So if you test a point, let's say you pick a point right here. You plug that into your equation, and it works. If it works, you're supposed to shade the side that it's on. So this is on the inside, so you're going to shade inside of that parabola. Now, let's say that it didn't work. So you plugged it into the inequality and it did not work out. That means you're going to shade the outside part of this parabola. Okay, so that's basically what we're doing. Now, using this one, to graph this one, you can do this in a couple of ways. You can use the formula x equals negative b over 2a to find the x value, take that, plug it back in. You can complete the square, turn it into vertex form, that way you know the vertex. I think in my class, a few people actually completed the square and turned it into vertex form. Either way is fine. So I'll go and do it the same way that we did it in class. So you would group these two to turn into vertex forms. That'd be y is greater than, then be x squared minus 2x, just a new piece, minus a 3, and then you'd add on a new piece there. So you take half of the negative 2, which is a negative 1, square it, and you get a 1. Now you're going to add a negative 1 on, because in order to work only on one side, once you add the 1 and you subtract 1, that's like you didn't do anything at all. So you're not actually changing the inequality. So this is y is greater than x plus, not plus, sorry, x minus 1 squared minus a 4. All right, so there you have your vertex, which is positive 1, negative 4. As an extra point, you can use, you can plug in 0 into the original, because remember, this original equation and inequality and this inequality are equivalent. They're actually the exact same thing. I just made it look different. So I can plug in a 0 here and get a negative 3. So an extra point is 0, negative 3. All right, so plotting that. Let's see here, dual page. Let's make this a little bigger. So 1, negative 4, it's right here. That is your vertex. 0, negative 3 is right here. Using your axis of symmetry, you know that you have an extra point right there. So 3 points is enough to make my parabola. Now looking at this, I do not have an equal sign under here. That means that this will be dashed. So I'm going to dash this when I connect it and make my parabola. So that way and that way. All right, so there's my parabola. Now my next thing is I got to test a point either inside or outside. Now you can test any point you want anywhere on here. Does not matter where. I would suggest plugging in somewhere, a point that's on the y-axis, just because then your x values will be 0. Like for example, this point right here is 0, 3, which is right here. That's obviously inside of my parabola. 0, 3, I'd plug in as 0 for x, which would make these two very easy to work with. So pick any point you want. You can even try 0, 0. 0, 0 is inside. So I'll mark the point that I'm testing here in red. So I'm going to test that point right there. So test 0, 0. So if you test 0, 0, you'll get 0 is greater than 0 squared is 0, minus 2 times 0 is 0, minus 3 would be at negative 3. And that is true. 0 is greater than negative 3, so this point actually did work out. So you're shading everything inside of here. Keep in mind the shading represents solid. You know what? Let me make mine a little bit nicer. I'm going to use a highlighter. So everything inside of here gets shaded. Now it's more than this, basically because those arrows on the end of the parabola keep going. So it's more than that. Keeps going up, but that's basically your answers. Your answers are everywhere inside of there. Okay, and move on to the next one. So example 2. Just like at the beginning, you can have different forms. You still need to graph it. This one is still dashed. If there's a line under it, it'd be solid. So this one is in vertex form. So it's already in vertex form, ready to go. So vertex is going to be positive 3, positive 1. An extra point. I'm going to pick 3 as my x value for my extra point. Those of you wondering why I picked a 3, I'm wondering that as well. Hold on. Wait, no, that won't work out. I won't use that because 3 was already picked as our number. So yeah, never mind. So that's not going to be our vertex. Let's go ahead and pick a different number. So any number you want is going to work out here. You try to pick it kind of wisely. That way you'll work with these numbers well, but there's no fractions here. So any number will work. So 3, I'll pick a number near the 3. Let's pick a 2. Oh, that's still like that. There you go. All right, pick a 2. So you plug a 2 in. If I plug a 2 in here, that'll be negative 2. 2 minus 3 squared plus a 1. Negative 2. 2 minus 3 is a negative 1 squared plus a 1. Negative 1 squared is a 1 times a negative 2 is a negative 2 plus a 1. Okay. And this will be a negative 1. All right, so basically what we did was we just picked an extra point because we need at least 3 points. In my class, I want 3 points to make your parabola. So I picked a point near the 3, which was a 2, plugged a 2 into here. I made it equals because I'm actually finding a point. I'm not actually trying to evaluate this yet, so I'm just finding a point so I can make it equal. Just double checking my work. That way I don't have to give out extra credit if you find a mistake. All right, so 3, 1. 2, negative 1. Using my axis of symmetry, I know that there's one on this side also. So this will be a parabola dashed going upside down. All right, so with this one, I can pick any point that I want inside of here. Doesn't really matter where. I can pick a point outside too, so I can still try 0, 0 right here. That might not necessarily be the best point to pick. So I'm going to pick negative 3, 0. Yeah, I'll pick negative 3, 0. So negative 3, 0 is right here. Remember, you can pick a point outside. So if it's working, if it actually works, I'm going to shade the inside. If it doesn't work, I'm going to shade the outside. So plugging that in, so I'm going to test point 3, 0. You'll end up with 0 is greater than negative 2 times 3 minus 3 squared plus 1. I pick that because negative 3 minus 3 is a 0. 0 squared is a 0 times negative 2 is a 0, so you get 0 is greater than 1. So negative 3, sorry, 3 is 0. So is 0 greater than 1? No, it is not. Nope. So this point inside did not work. So that didn't work out. That means I'm shading the outside part. So outside part is everything out here. You don't have to go this wild with it. There's the bell. So, okay. So it's all the stuff on the outside of the parabola, nothing on the inside. Those are all of your solutions. Okay? And that's how you graph them. Just make sure you know if it's dashed or solid and then where to shade. All right. There we go. Now we're going to solve. Solving an inequality algebraically. Now, what's happening here is this. I told you guys in the past that when you're solving something, when you're solving a quadratic, what you're actually finding when you're solving a quadratic is this. Whoops. So let me set this up. Let me put a shape on here. Sorry. It should have all been set up already, but anyways. So let's say you made your parabola. Now, every parabola that you draw comes from an equation. When you actually solve an equation out, what you're actually finding are your x-intercepts. It's where your graph touches the x-axis. So when you're solving an equation, you're finding where the graph touches the x-axis. So for example, I'm just making these numbers up, but let's say this was y equals x squared plus 7x plus 3. That's not the equation. That doesn't match up with this one, but I'm just saying, let's say that this matched up with this. And then you found these two x-intercepts, and you said, okay, I want to solve this. So I can graph this, I come up with this graph, but then if I said I wanted to solve this equation out, this would actually turn into a 0 equals x squared plus 7x plus a 3. So solving this will actually get you, when you turn a y into 0, you're actually finding your x-intercepts. That's the method of finding x-intercepts, turning your y into 0. So solving an equation like this is the same thing as finding the x-intercepts of this equation. Okay, it's where your graph touches your x-axis. So going back a little bit, let's look at this one. Actually, just go back to the first one. So this first one that we drew, if you think about this graph as a whole, it's not just this parabola, it's all the shading that's happening on the inside too. So if you think of all the shading and where it touches the x-axis, our graph touches the x-axis everywhere between, so if you think of this as your x-intercept here and x-intercept here, our graph touches the x-axis all of these places between, it looks like almost -1 and 3. So your answers are all your x values that are between 3 and -1. So if I was going to ask you guys to solve that equation instead of graphing it, that would be your answer, because any x value that you plug in between those two are going to work if one side is equal to 0. So that's actually what we're looking at. We're looking at, if I was to graph this, where does our graph touch the x-axis? Now, obviously, this is a little bit inaccurate, so I'm going to teach you guys an algebraic way of doing this. All right, so first, replace the inequality symbol with an equal sign. That will turn into an equation, quadratic equation. Once you have a quadratic equation, you're going to solve that equation. Once you solve that equation, you're going to plot the solutions, also known as critical x values, that you found in step 2 on a number line. That number line is actually going to be your x-axis. All right. We don't really care about the y-axis because we're just solving for x's, so x-axis. And step 4 is to test the point. And then, so test the points between and, oh, sorry about that. Lost my place. So step 3, plot the solutions, critical x values. Step 2 on a number line, that's going to be your x-axis. Step 4, you're going to test points between and beyond the critical x values to find solutions to the inequality. So a lot of steps here, but it's actually not too bad. Solve the quadratic inequality algebraically. Now, if you notice, this equation right here was actually the same thing as this equation right here. Only I put a 0 in right here. So it's the same problem, I just put a 0 on the side. So if you look at this, we already know our answer is going to be from here to here. So I'll show you how to do this without actually having a graph though. All right, so to solve this, first step is turn it into an equation. So x squared minus 2x minus 3 is equal to 0. So remember, we're finding our x-intercepts right now. So that's how you do that. Now, you can do this one of three ways. You can complete the square, you can try to factor if it's factorable, or you can do the quadratic formula. I don't really care which method you use. This is factorable though. X and x should be 1 plus, 1 minus, factors of a negative 3, or 3 is so 3 and a 1, and that's it. Okay, so x plus 1 equals 0, or x minus 3 equals 0. Therefore, x is equal to negative 1, or x is equal to positive 3. Now, you're not done. That doesn't really tell you much of anything. All that tells you that is if you're gonna graph this thing, then your x-intercepts would be there and there. So that doesn't help. So what we're gonna do right now is figure something else out. So basically, we know that at negative 1 and at 3, we have some x-intercepts. Now the problem is I need to figure out where the shading happened, because all I care about is where it intersects. So either we're going to draw a parabola and it's going to intersect with that part, because that'll be inside of the parabola, or it'll intersect with these outside parts because that's outside of the parabola. All right, so if we, what did this parabola look like? Forgot. So this parabola apparently looked something like, wait, it was dashed. Okay, so either it's going to shade inside or outside. We already know it's going to shade inside, so we know the inside part is going to be our answer. But I said I wanted to show you this without graphing. So you do have to kind of graph because all I'm considering is the x-axis. So this is at negative 1, this one's at 3. I'm not considering the y-axis at all. So my critical points are here and here. Now what I'm going to do is I'm either going to test a point between those 2 points or outside of those 2 points, because it's only going to have one of those answers. So what I'm going to do is go ahead and test a point in between them. So I'll try this 0. So plugging in a 0, if I plug in a 0, it'll be 0 squared minus 2 times 0 minus a 3. It's less than 0. This is negative 3 is less than 0, so that actually works out. So I know the shading happens in between here. And that is a compound inequality. So that is x values have to be between, not equal to. All right, so actually that'd be like open circles. X is between 3 and negative 1, and that's your answer. Okay, and that's how you do that part. Next part. So this one, example 4, is actually a lot like example 2. If you remember example 2, it was this. So example 2, looking at this, the shading was on the outside of this parabola. So considering the shading is part of your graph, that means that all this stuff outside the parabola on the x-axis are your answers. So let's say your x-intercepts are here and here. That means that your answers are going to look like this. All right, and that's an OR compound inequality if you remember what those look like. So let's go and try that out and see if it actually works out like that or not. So with this one, to solve this one, first you put an equal sign. So I'm going to go ahead and flip this around too. So negative 2 x minus 3 squared plus 1 is equal to 0. So I just switched around because I like the x's on the left-hand side. So minus 1 minus 1, negative 2x minus 3 squared equals a negative 1, and divided by negative 2. 2's are gone. X minus 3 squared equals 1/2. All right, now we're going to take the square root of both sides. We're going to get x minus 3 equals plus or minus, so square root of 1/2, so square root of 1 over square root of 2. So that's going to be square root of 2 over 2. All right. we did this in class, how to do that out. So that was basically square root of 1 over square root of 2 multiplied by square root of 2 over square root of 2. That's going to be square root of 2 over square root of 4, which is a 2. That's how we got that. Then we're going to add 3. All right, so we're going to get x equals 3. Whoa, that was a weird 3. 3 plus square root of 2 over 2, or x equals 3 minus square root of 2 over 2. Now you can actually plug this into the calculator. So let me bring a calculator up. So 2 square root of 2 divided by 2 equals that, and then you're going to add 3 to that. So that's going to equal 3.7 approximately. So x is equal to 3.7. So square root of 2 over 2 is basically approximately 0.7. I think that's what it was. 2 to square root divided by 2. Yeah, so square root of 2 over 2 is like a 0.7. So this one is basically going to be 3 minus, this is like a 0.7. So 3 minus 0.7 is 2.3. All right. So these are your x-intercepts. So 3.7, 2.3. Let's see if that actually looks like where we were at over here. So 3.7, it's right here. 2.3, it's right here. So it looks like our graph was about right. And now let's test a point. Now, according to our graph from before, it should work on the outside parts of this. So remember, but with this one, we wouldn't have the graph already. So if you want to actually do this one without the graph, you'd have to draw your x-axis. This is 2.3. This is 3.7. I'm going to test a point inside. Actually, outside would be easier because it's easier to plug in. So let's come back up here. Let's try a 3, because 3 minus 3 will be a 0. So, oh yeah, so that's inside. I'm kind of out of it right now. So let's try a 3. I can go up again. I'm tired of going up. Okay. Copy. All right, so we're going to plug into this guy. See if it works or not. So let's plug a 3 in here. All right, so that'll be 0 is greater than negative 2. 3 minus 3 is a 0 squared plus a 1. That's going to be 0 is greater than 1, which is not true. So this point inside of here, this one did not work. Since it did not work, I know that I should shade the outside parts, because that will be where my graph will intersect the x-axis. So to write that, that's an OR compound inequality. Once again, these are open circles because there is no equal sign. So this will be x is less than 2.3, or x is greater than 3.7. Now, I actually don't want you leaving it like this. I turn it into decimals just so you can kind of see where they're at on a number line. But remember, this is the same thing as this stuff right here. So the 2.3 came from this one. So actually, instead of putting 2.3, I want you writing this out right here. All right. So this will be, this will be x is less than 3 minus square root of 2 over 2, because that is a more exact answer. Or x is greater than 3.7, but 3.7 came from 3 plus square root of 2 over 2. That's a square root. All right, and that is your answer right there. So that's how you do that. So you can turn it into decimals just so that you can get an awareness where it's at on a number line. But after you're done turning into decimals, since decimals are technically a little bit wrong since you had to round off, I do want you turning it back into rational form. All right, and that is it. So make sure you finish that worksheet I gave you tomorrow, and that's all. Okay, bye-bye. Bye.